Okay, here we are. This is Finite Math, Chapter 2. We're doing Section 2 today, which is really an extension of 2.1. And what I'm going to do is talk about the concept of pivoting, which they talk about in the book. And then from there, I'm going to use that in solving more problems. And I already tried to solve a few problems in 2.1, so you've got a pretty good idea what's coming. So we're just going to try to refine that idea. Okay, so when you pivot around a certain element in the matrix, it means we want to get a 1 in the desired location and then zeros every place else in that column. So let's look at my first example here. And the matrix is 2, 1, 6, 3, 5, 9, and I want to pivot around that 2. Okay, so that means we want to get a 1 where the 2 is. And if you remember previously, I said if you want to get a 1, multiply by the reciprocal. So the reciprocal of 2 is 1/2. So what we're going to do, we're going to take 1/2 of row 1. So half of 2 is 1, and that becomes my pivot. Half of 1 is a half, and half of 6 is 3. The second row stays the same. Remember, you can only work on one row at a time. So that takes care of when you go up here, it says get a 1 in the desired location. So I got a 1 where the 2 was. Now I want to get zeros everywhere else in that column. Well, there's only one to get, and that's where the 3 is. So the top row stays the same. Remember, you only do one row at a time. To get a 0, if you'll remember what I told you before, I said multiply by the opposite. So the opposite of 3 is -3. You multiply the opposite times wherever the pivot is, that's row 1, and add it to row 2. I'm going to stop putting the arrows in there. -3 times 1 is -3 plus +3 is 0. -3 times a half, that's -3 halves. Think of that as 10 over 2, so -3 and 10 would be 7 over 2, and -3 times 3 is 6, -6, -6 plus 9 is 3. And I'm done. I pivoted around the 2. That means I made the 2 into a 1, which changed everything else in its row, and then I got a 0 every place else in that column. So where the 3 was, I ended up getting a 0, and that gave me the new numbers. And that's all you had to do. Let's do another example. Same type of problem, we're going to pivot. This was actually in the book. This one says pivot around the -6 right here. Probably make you guys dizzy moving these papers around. So that means we want to make the -6 into a 1. So we're going to multiply by the reciprocal. The reciprocal of -6 is -1/6 times row 1. So -1/6 times 18 is -3. -1/6 times -6 is 1. That's my new pivot. And -1/6 times 15, that's -15 over 6, or in lowest terms, that would be -5 halves. The bottom stays the same. Okay, so we got the 1. Now we want to get a 0. Top row stays the same on this one because I got the 1 in there. So I want to make the -2 into 0. So you multiply by the opposite. The opposite of -2 is +2. Times row 1, because that's where the pivot is, plus row 2. So 2 times -3 is -6. -6 plus 5 is -1. 2 times 1 is -2. 2 plus -2 is 0. And 2 times -5/2, the 2's drop out. That's -5. -5 plus 4 is -1. And that's all you have to do. Now, I will say this. We don't normally pivot around items that are not in that main diagonal. So if you think about it, let's say we have a 2x2 system. And I'm just going to put lines here. It's a 2x2 system, even though I got 3 columns. You got an X column, a Y column, the answer column, and then 2 equations. If you're working one like this, on most problems, we're always going to get this guy first. In other words, we're going to pivot around the first element, first row. Then once you have a 1 in that column, then you're going to get a 0 below it. So you do this one first, that one second. Then we go to the next column. Now in a 2x2, remember we talked about that diagonal? That means this would be the next thing I would do because I got to get a 1 there. And then once I have a 1 there, I'll get a 0 up here. And once you have a 1, a 0, a 1, and a 0, then your answers will be over here. So we would always do them in that order, if that helps out. Okay, let's say we have a 3x3 system. So that means we have 3 equations. We got an X column, a Y column, a Z column, and then we have what I call the answer column. Sometimes they call it the constant column. Okay, we would always start up here. First row, first column. And then we would, once we got a 1 here, then we get zeros everywhere else. So we probably do this one second and this one third. And that would give you a 1, 0, 0. Now, once the first column's done, then we go to the second column. And you're thinking in terms of that diagonal, we want to get a 1 on the diagonal. So this would be the next one you do. So I want first, second, third. This would be the fourth one you do. And once you got a 1 here, you're probably going to get a 0 up here and a 0 down here. Now, honestly, once you get a 1 in this spot, you're going to get a 0 above and below. It doesn't matter which one you do first. I just put 5th and 6th. Then you go to the third column. We need to get a 1. So this would be the 7th one we do. And then I'll just say this is the 8th and this is the 9th. So if I was doing this, you get a 1, you get a 0, you get a 0. Then you're going to get the 1 here. You get a 0 here and a 0 here. And it really doesn't matter which one you get first. It really doesn't matter which one you get first on those two. It doesn't matter which one you get first there. And then when you go to the last column, you're going to get a 1. And then it doesn't matter which one you get first, but you 2 zeros. And then you get whatever's over here. Those are your answers. So it helps to know the order in which you're going to work all of those. Okay. Okay, so I did my 2 examples on pivoting. Okay, let's put this over here. Okay, when you read in the book, they give you this blue rectangle that I have here. Okay, now we're going to apply that pivoting concept. And it's the same thing I showed you in section 1. I'm just being a little more definite with it and put more organization to it. But the Gauss-Jordan method to transform a system of linear equations into diagonal form. So if you're going to use the Gauss method system, these are the steps. First of all, you write down the matrix corresponding to the linear system. Fine. Then you got to make sure that the first entry in the first column is non-zero. If it's not, then what you're going to do, you're going to switch rows to get a non-zero. Okay, then once you have a non-zero in a first, you're going to pivot around that first element. Once that's pivoted, then we go to the second column, and you want the second entry in the second column to be non-zero. If not, you interchange by a row that's below it. Once you have that, then you're going to pivot the matrix around that one. Now, if you were a 2 by 2, you're done. But if you have more, then you're going to continue in the same manner on a 3 by 3 or a 4 by 4 until you get it in diagonal form. And once you have that, number 7 basically just says, okay, you can write down your answers. Okay, all those words, those are really nice and everything, but until you see it in action, doesn't mean a whole lot. So let's do a couple examples here. So I've got several examples. Okay, so determine all the solutions for this system. So the first step is we're going to write that as a matrix. And you're pretty good at this now. If this is all you had to do, you'd be pretty good. Be in good shape. Okay, so it says up there that we want to get a non-zero number in that slot. That's what number 1 tells you. Well, okay, you're good. So the next step is we got to get a 1. Now, there's actually 2 ways of getting it. Either one will lead you on to the correct answer. I'm going to show you the easy one. See this right here? See how you get a 1 in the second spot? What if we just switch the rows? So we're going to take the second row and put it first, and first row and put it second. And we'll keep the last one the same. This is something you always want to look for to keep your answers simple. Now somebody's going to say, well, Mr. Chu, you said that to get a 1, we multiply by the reciprocal. That's true. And I could have multiplied through by a half, but if I would have done that, I would have got halves in here. In other words, I would have had fractions, and that makes your work a little bit tougher. So I bypassed a way of coming up with fractions. And then don't forget to put your instructions out front. And all we did was switch row 1 and row 2. Make sure your instructions are in front of the row you're going to. So we started with this matrix. Here's our instructions, and that's what we got out. Every once in a while, I'll get somebody who puts the instructions here, and I get all confused. And you don't want me confused, because then I kind of give up trying to follow your work. Okay, we're going to circle that because that's my pivot, and I'm going to pivot around that and get zeros below it. So the top row is going to stay the same. To get a 0 here, I'm going to take -2 times row 1, add it to row 2. So -2 times 1 is -2, plus +2 is 0. -2 times -1 is 2. 2 plus 1 is 3. All I'm doing is take out -2 times each of these and add to each of those. -2 times 1 is -2, plus 1 is -1. -2 times 1 is -2, plus 4 is 2. Now we're going to get a 0 here. We'll take -3 times row 1 plus row 3. When you're getting zeros, you can do 2 rows at a time. Earlier I said only one thing at a time. You can do 2 of them. But if you got a 3 by 3, you can never ever do 3 rows at one time. Okay, -3 times 1 is -3 plus +3 is 0. -3 times -1 is 3. 3 plus 1 is 4. -3 times 1 is -3 plus -1 is -4. And -3 times 1 is -3 plus +3 is 0. And the good news is we still don't have any fractions. Okay, so when you look at the first column, it's done. I got a 1 and I got 2 zeros, so I pivoted around the first element. Now, according to the instructions up here, it says, make sure the second entry in the second row, second entry, second row, that's the 3. We got to make sure it's non-zero, and if not, I'd interchange it with one of the rows below it. We're okay. I have to get a 1 where the 3 is. So the top row is going to stay the same. Just copy those. The second row, I got to change the 3 into a 1. So I'm going to take 1/3, that's the reciprocal of 3, times row 2. So 1/3 of 0 is 0. 1/3 of 3 is 1. That's going to be my new pivot, so I'm going to circle that. 1/3 of -1 is -1/3. And 1/3 of 2 is 2/3. And the bottom row stays the same. The only time you can work on more than one row at a time is when you're getting zeros. Okay. Now that I have the 1 here, I got to get a 0 above it. What can you do to this row? Combine it with this row to get a 0. All I have to do is add. All I have to do is take row 2 plus row 1. Row 2 comes first because that's where the pivot is. I didn't line that up very good. It should be lined up there. But 0 plus 1 is 1. 1 and -1 is 0. There's your 0. -1/3 plus +1 is going to be 2/3. Think of that as 3/3, 3 over 3. 3/3 and -1/3 is 2/3. And same thing here, 3/3 plus 2/3 is 5/3. Second row stays the same because that's where my pivot was. And then we want to get a 0 here. Remember, we're pivoting around the 1, which means we're getting zeros in the other two spots. So to get a 0, I'm going to take -4 times row 2. I'm going to add it to row 3. Oops. Put my answers in row 3. So -4 times 0 is 0, plus 0 is 0. -4 times 1 is -4, plus +4 is 0. -4 times -1/3, that's going to be a +4/3. Think of that as 12/3. So 4/3 and 12/3 is going to be 16/3. Now, make a comment here. Some of you guys will want to take that and write that as 5 1/3. Leave it as 16/3. 5 1/3 is awful hard to work with. As this is called I forgot what it's called. Well, anyway, let's move on. And 4 times 2/3 is 8/3, plus 0 is 8/3. Okay, we're almost done. So we got a 1 and 2 zeros. We got a 1 and 2 zeros. So now we go to the third one. Remember, where's the 1 going to be? It's going to be right here. So I'm going to pivot off of that. Top row is going to stay the same. Second row is going to stay the same. They stay the same because the only thing I'm going to do is get a 1 here. And to get a 1, I'm going to multiply by the reciprocal. The reciprocal of 16/3 is 3 over 16 times row 3. So 3 over 16 times 0 is 0. 3 over 16 times 0 is 0. 3 over 16 times 16/3 is 1. That's going to be my pivot for the third column. And 3 over 16 times 8/3, the 3's drop out. 8 over 16 is going to be a half. Now, if you're real smart, you're going to realize Z is going to be a half. Okay. Now that you got a 1 here, you got to get 2 zeros. So the bottom row, I'm going to put the bottom row in because it doesn't change. Okay. So let's say I'm going to go up. I'm going to get a 0 where the -1/3 is. So the opposite of that is going to be 1/3. So I'm going to take 1/3 times wherever the pivot is. The pivot's in row 3 now. I'm going to take 1/3 of this and add it to the row I'm working with. So 1/3 times 0, 0, plus 0 is 0. 1/3 times 0 is 0, plus 1 is 1. 1/3 times 1 is 1/3, plus negative 1/3 is 0. And 1/3 times 1/2. 1/3 times 1/2. I'm going to come over your side here a little bit. I'm taking 1/3 times 1/2 and adding to 2/3. 1/3 times 1/2 plus 2/3. So over here on the side, that's going to be 1/6. You need a common denominator, so we're going to make 2/3 into something over 6. That's going to be 4. 4/6 and 2/3 is the same thing. So when you do that, you get 5/6. That's the number that goes right here. Okay, now we're going to go to the top. I want to get rid of the 2/3. I want to make that into 0. So we're going to multiply by the opposite. The opposite is 2/3. So we're going to take 2/3 times row 3. That's where the pivot is. Add it to row 1. So 2/3 times 0, 0, plus 1, still 1. And as you go along, once you get 1s and 0s, they don't trade off at all. Okay, 2/3 times 0, 0, plus 0, 0. 2/3 times 1, oh, I'm sorry. That should have been negative 2/3, because that's positive. The opposite would be negative 2/3. So negative 2/3 times 1 is negative 2/3, plus positive 2/3 is 0. That didn't change the other two numbers. And then we're going to take 2/3 times 1/2. We'll put it over here. We'll take negative 2/3 times 1/2, and I'm going to add that to 5/3. Negative 2/3 times 1/2 plus 5/3. That's what I did here. Negative 2/3 times 1/2 plus the 5/3 on top. So when I do this, let's see, these 2's drop out. That's going to give you negative 1/3 plus 5/3, and that's going to be 4/3. And it's okay to do this on the side. Just make sure it doesn't interfere with your matrices over here. I do that stuff all the time. And then step 7, on that blue rectangle a minute ago, you'll notice we got it in diagonal form. You can see my 1s and 0s every place else. So that means that the x value will be 4/3, y is going to be 5/6, and z is going to be 1/2. And then, of course, you could always plug those in to see if you got the correct answer. We're going to bypass that. I'm more concerned about showing you how to work the problem. And perhaps I made a mistake in there. I hope I didn't, but who knows? Okay. Now we're ready for example 3. I think I just did 2. Yeah. Okay. Okay, so on this one, we're going to have 1, negative 1, 1, 3, 1, 1, negative 1, 5. I didn't line that up very good, did I? Negative 2, 4, negative 4, 1. Make sure you get these all lined up. Sometimes when I'm hurrying looking back and forth, I don't get them in the right places. Okay, so we're going to save a step because we've already got a 1 here. I'm just going to circle that, and that becomes my pivot. And nothing changes here. Now I'm going to get a 0 here. All I have to do is take the opposite of row 1 and add it to row 2. So negative 1 plus 1 is 0. The opposite of that is 1. 1 plus 1 is 2. Negative 1 and negative 1 is negative 2. Negative 3 and 5 is 2. Going to the bottom to get a 0, I'm going to take 2 times row 1, add it to row 3. So So 2 and negative 2 is 0. 2 times negative 1 is negative 2. Negative 2 and 4 is 2. 2 times 1 is 2. 2 and negative 4 is negative 2. And 2 times 3 is 6. 6 plus 1 is 7. Okay. So the first column is done. We go to the second column. We want to work on this too. We got to get a 1 there. So the top row stays the same. So to get a 1, I'm simply going to take 1/2 of row 2. Half of 0 is still 0. Half of 2 is 1. That's going to become my pivot. Half of negative 2 is negative 1, and half of 2 is 1. And the bottom stays the same. Okay, now I want to get a 0 here, so I'm simply going to take row 2 plus row 1. So 0 plus 1 is 1. 1 and negative 1 is 0. Negative 1 and 1 is 0, and 1 and 3 is 4. Second row stays the same. Now we've got to get a 0 here, so we're going to take negative 2 times row 2 plus row 3. So negative 2 times 0 is 0, plus 0 is 0. Remember, they're not going to change. Negative 2 times 1 is negative 2, plus positive 2 is 0. Negative 2 times negative 1 is 2. 2 plus negative 2 is 0. Negative 2 times 1 is negative 2. Negative 2 plus 7 is 5. Okay, so you notice something here. The first two columns are done. I'm ready to go to the third column, which means on the diagonal, I want to get a 1 here. I can't. You cannot get a 1 if there's a 0 there. That means since you cannot go further, you cannot put that in diagonal form. That means you cannot go any farther on the problem. You know the answer. The answer is no solution. If you go back to the problem up here, I didn't read it for you, but it's this one says solving a system of equations with a unique solution. That was the last one. This one says a system of equations with no solution. Okay, so we get that down to a point where we could read it. Since I can't get a 1 here, I can't go farther, so there's no solution. You know, and another way of thinking of it, and I think this is easier, this is like 0x plus 0y plus 0z. That means over here, 0x, 0y, 0z, that's 0, should be equal to 5. Is 0 equal to 5? Never. That means there's no solutions. It's never going to happen. Okay. Let's move on. Okay, on this one, everything's the same except this one says we have infinitely many solutions. So let's see what happens on this one. So I get 2, 2, 4, 8, 1, negative 1, 2, 2, negative 1, 5, negative 2, 2. Okay, that's the easy part. I'm going to mark this down. This is example number 4. Okay, so we got to get a 1 here. You have two choices. You could multiply everything by 1/2, or you could switch rows if you wanted to. I'm going to multiply by 1/2 because that's what most of you guys would have done. The way I've taught you, it's kind of ingrained in your brain. So half of 2 is 1. That's my pivot. Half of 2 is 1. Half of 4 is 2. Half of 8 is 4. The others stay the same. When you're getting a 1, you only do one equation. When you're getting zeros, you can do multiple equations. Okay, top row is going to stay the same. And I'm pivoting around that 1, so I want to get zeros. So I'm going to take negative row 1 plus row 2. So negative 1 plus 1 gives me 0. Negative 1 and negative 1 is negative 2. Negative 2 and 2 is 0. And negative 4 and 2 is negative 2. And on the bottom row, all I have to do is take row 1, add it to row 3. So 1 and negative 1 is 0. 1 plus 5 is 6. 2 and negative 2 is 0. 4 and 2 is 6. Okay. First column's done. Now I want to pivot around the negative 2. Second row, or second element in the second column. So the top's going to be the same, and I'm going to get a 1 in the bottom, so I'm going to take negative, or in the second row, so negative 1/2 times row 2. So negative 1/2 times 0 is 0. Negative 1/2 times negative 2 is 1. That's my new pivot. Negative 1/2 times 0 is 0. Negative 1/2 times negative 2 is 1. And the bottom stays the same. Okay. So I want to get a 0 here, so I'm going to take negative row 2 plus row 1. So 0 and 1 is 1. Negative 1 and 1 is 0. 0 and 2 is 2. Negative 1 plus 4 is 3. Second row stays the same. I want to get a 0 here, so I'm going to multiply by negative 6 times row 2. I'm going to add it to row 3. 0 and 0 is 0. Negative 6 times 1 is negative 6 plus positive 6 is 0. Negative 6 times 0 is 0. 0 plus 0 is 0. Negative 6 times 1 is negative 6. Negative 6 plus 6 is 0. First column's done. Second column's done. Look at the third column. I need to get a 1 in that spot right there. Remember, you can't do it. If you got a 0, you can't get a 1 there. It's impossible. But notice the difference between this one and the other one. Remember the other one we end up with 0 equals 5 on the bottom? Look what we got here. That's 0x, 0y, 0z. So on the left side you got 0, and on the right you got 0. Okay, when is 0 equal to 0? Well, it's there all the time. So your answer on this one would be, you don't have one unique solution. You have infinite solutions. Okay. Got two more examples. Okay, and both of these are going to end up being infinite. Okay, so here's number 5. So I'm going to go 1, 2, negative 1, 3, 5. Then I got 1, 2, 1, 7. This would be a 0 because I don't have any x's in that one. Now you can tell right away there's something wrong because I've only got 2 rows and I got 4 columns. Okay, I got a 1 here. Good. I got a 0 here. Good. First column's done. Okay, the diagonal goes this direction here. I want to get a 1 here. I've already got it. Okay, so the next step is I want to get a 0 here. So that's going to be negative 2 times row 2 plus row 1. So 0 and 1 is 1. Negative 2 and 2 is 0. Negative 2 times 2 is negative 4 plus negative 1 is negative 5. Negative 2 plus 1, or times 1 is negative 2 plus 3 is 1. Negative 2 times 7 is negative 14. Negative 14 plus 9 is negative, or 5 is negative 9. And this row stays the same. Now, you could have seen this from the very beginning, but the first 2 columns are done. But the problem is, I don't have enough rows to get these into zeros. Okay, now here's another way of thinking of it. Okay, so we have 2 rows here. And I'm just looking at the variables, but across here we got 4 columns. Think of rows, and you're not going to see this in a textbook. This is just something I came up with. But rows are ways of getting into trouble. Columns are ways of getting out of trouble. So in this one here, we have 2 ways of getting into trouble, but we got 4 ways getting back out. So if we get into trouble one time here, we got one of these, we're back out of trouble. I still have another way of getting in trouble. I use one of those. I still have 2 ways of getting out. It's like a get out of jail free in Monopoly, if you've ever played Monopoly. I have more ways of getting out of trouble. Okay, that means I have more variables than I need. Whenever that happens, when this number here is bigger than that number, that means it's infinite. If you turned it around, maybe if I had 4 rows, that means 4 equations, 4 ways of getting in trouble, and I had 2 columns. Now I have 4 ways of getting in trouble, but only 2 ways of getting out. Well, I could get into trouble, but I could get out with one of those. I have another way of getting into trouble. I could use the other one, but that still has 2 ways of getting into trouble. Getting into trouble indicates that you can't get out of trouble, which means you would have no solutions. So as you go through these problems, a lot of times you can look and you'll know the answer before you even get started. Okay, so let's look at this one. So if I rewrote this one, I got x minus 7y plus z equals 3, so that's 1, -7, 1, 3. And I got 2, -14, 3, and 4. So I've got 2 ways of getting into trouble and 3 ways of getting out. This is going to be an infinite solution. Okay. Just be aware that most of the problems that you're going to do will have what they call a unique solution. A unique solution goes back to, pick one of those examples I had. This is example 3, where we took the equations, got the matrix, we worked it all the way down, and when you get down, you have an ordered triple. That is a unique solution. That is considered a point in space somewhere. When you have 3, it's a 3 by 3, so it's not 2-dimensional, it's 3-dimensional. Okay, and what I mean by that, let's go back and talk about this. I'm really talking more than I wanted to. If we were 2-dimensional, most of the problems we do will have 2 lines. And when you think of 2 lines, you think of 2 lines that intersect in a point. That point is the unique solution. It's a point. There's one and only one. That's what unique means. But sometimes those lines don't intersect. They might look like this, where they're parallel. So if you can imagine, the solution is where the lines intersect. If they don't intersect, okay, that means you have no solution. No intersection, no solution. Okay, and then a third situation would be this. I could have a line, and sometimes you could have the same equation. I'm going to show you in a second. But let's say I know this line goes through that point, and then I come up with another line. It goes through the same 2 points. So what you really have is the same line. When that happens, That is an infinite solution. Infinite solution. And even when you go to 3 by 3, you still have the same things going on, but you can't draw pictures of it because it's in space. It's three-dimensional. Okay, I'm going to give you an example of when you can look at something like this. Let's say I got the equation x plus 2y plus 3z equals 10. And let's say my second equation is 2x plus 4y plus 6z equals 20. What you'll notice is everything in the second equation is twice as big as the first. So in other words, one is a multiple of another. When that happens, you're going to get the same line, which is infinite. One equation is a multiple of another. That means it's going to be infinite. Eventually, if you worked it all out, everything drops out. I probably shouldn't have put this in. Just keep it two-dimensional. But when they're multiples each other, they're really the same line. Okay, now what if I had this one? What if I had, I'll keep it two-dimensional, x plus 2y equals 10, and 2x plus 4y equals 7. So as you work with these, you start getting pretty good at these, and you say, okay, I doubled this one, I doubled this one, I did not double that one. Everything is the same over here, but it's different over here. When that happens, then you're going to have no solution. Eventually you get to the point where everything drops out. And then you get like a 0 equals 5 or 0 equals something else. Okay, I'm going to stop there. That takes care of section 2.2. Probably went a little longer than I wanted to, but I thought that was good. It was good practice. And like I said, it's a continuation of section 1. We just got a little more in depth with it and put the method to it. And we also talked about no solution and infinite solution. Okay, see you next time.